So anyway, just a short overview about us. So we're, I would call us a scale-up. So we are less than 2 years old, but we're quickly scaling. So we have over 60 team members worldwide. We have more than 50 public partnerships and large clients, amongst which are corporations or public institutions, such as the United Nations or the EU's R&D branch, the EIT Food. And we also have a large community. So we have our own cryptocurrency that's powering the network. And we have right now actually more than 150,000 people worldwide who hold our cryptocurrency and participate in the network in one way or another. In terms of what we do, so practical aspects, so I think the previous speaker has set up the agenda, for why supply chains issues are serious and how they need to be addressed. So you have a bunch of problems that have been highlighted, and they're all related to the fact that we actually don't have enough information about where does the product come from, what happened to it, and how can you actually trace it and so on. And the problem is you cannot only answer it by blockchain. There are a number of companies working in the space saying that we're going to transform supply chains or the global trade using blockchain, but blockchain itself is a self-contained system. It's actually why Bitcoin is so secure is because it's a mathematically elegant formula powering a network, which is perfect, which is why Bitcoin itself has never been hacked. However, if we look at actually interacting with the real world, you then need oracles, which are the trusted source of information for the blockchain. Because blockchain itself, it's a funny thing, it's a repository of the truth. So once you give it the information will be there forever. However, blockchain cannot determine if you're feeding it the truth or the lies, because you can also have the lies being stored forever. So how do we actually bring real world data to the blockchain in a reliable manner? Well, you try and minimize the human factor, because all of the fraud and cheating is done by humans, and therefore the goal is to actually integrate IoT as much as possible, which is exactly our answer. So we combine blockchain with IoT elements. So these are the three pillars I've gone through. I'll give a bit more info about the blockchain part. And importantly, we also have different dApps, distributed applications, that you can build on Ambrosus ecosystem. So what this means is that we provide different SDKs, software development kits, and APIs for developers to build Ambrosus, iOS, or web applications using our blockchain. So we also try and increase participation in the ecosystem by providing entrepreneurs with the tools they need to take off a business. I'll skip through the blockchain basics and this part. Importantly, we're open sourced, so all the code is out there on the GitHub, so you can play out with any tools and build any applications or solutions that you're interested in. No license, no payment is needed, so it's free to use by everybody. If you're using the mainnet, of course, to post transactions and so on, then you do need to pay to the network participants to process the data and store it later on. In terms of secure end-to-end, this means that data integrity is assured at the source. It will take me too long to deep dive into how exactly it happens, but basically we make sure that the data is secured even before it reaches the blockchain. And we're also exhibiting here today, so for those of you interested after the talk, you're welcome to come to our stand and I can show you these devices and explain how that thing works. And in terms of the technology stack, I'll not dwell too long on this because I realize this audience is not necessarily technically minded, but just to illustrate, we work on multiple layers. So we work both on the protocol development as well as creating specific solutions and gateways. So if you take the internet kind of parallel with the internet, we're building both the HTTP level as well as the actual web pages and applications. I mean, ideally we want others to also come and build, which is why we're actively promoting this, but the work goes on multiple layers, and most consumers will never really interact with the first three layers. So the first two are really for blockchain core people. The third level is for any developers building a mobile or a web application, and finally only the dApps, only the last layer is the one where consumers interact with it. So this is basically your typical examples for the supply chain. Now, when we deal with the supply chain, we have multiple different stages for the product coming from suppliers all the way to the end consumers, and you always have black boxes over there. You have fragmented supply chains. I won't again dwell too long on this problem because I think the previous speaker has highlighted the problems. So the goal is to try and fill those black boxes with reliable data, especially in the industry where a lot of stakeholders don't trust each other. There are billions or sometimes trillions billions of dollars involved in the global trade, so there is a lot of incentives for people to obviously misbehave. I mean, just to give you one bit of statistics, in the US, only food mislabeling and fraud is about $60 billion annually. So that's just one tiny element of the scope of the problem. And on our side, we're solving this. I'll skip through this one, it's pretty technical. So here basically, this is the device that we're using, the so-called gateway. We have one at the stand where I can show you under the hood. Importantly, what it does, it validates the data locally. So this small device, it's, I have it on my table actually, not with me. It's basically more or less this clicker actually. You can put it anywhere. It has local connectivity via Bluetooth or otherwise. So it connects to local sensors in a container, takes their data, signs it cryptographically, and then sends it to the blockchain. And what this means is that the data, before it even reaches the blockchain, is already secured because the device itself has signed it. So we work with secure IoT as well as blockchain, providing data integrity for that. And then the protocols with which we can work, they can be anything. We don't really care about the protocols. So whatever suits the companies can be used for data transmission. Skip through this one. The number of applications, so it's basically limitless. So we're not, I mean, here I'm talking more about supply chain, but Ambrosus itself is positioning itself as really the kind of distributed IoT infrastructure. So supply chain is a major use case for us, but not necessarily the only one. But you can have, and these are all examples of what the applications or use cases we've already developed for our clients and partners. So once you have the reliable data about the location of your product, the ownership of the product, the environment in which the product finds itself in, and whatever other valuable information, you can build so many different valuable business use cases that companies can monetize. So the goal for us is really to create an ecosystem of startups building on our infrastructure, because each of these is basically a startup idea. So again, if there are any entrepreneurs amongst you or any people interested to launch solutions, we can definitely talk about this. Some of the markets highlighted here, I won't dwell on them too long because I think, again, the previous colleague has covered it. But again, each of these is basically a major problem faced by a lot of industries. And we specifically select those products that actually have the highest percentage of incidents or issues. We're also thinking about how you tag the object. So whenever we're talking about connecting physical to the digital, what does it practically mean? What it means is that if I have a pack of medicine, and if I have some information online or even on the blockchain about the medicine, how do I know that's the medicine I'm holding in my hands? So you need a method to tag an object. You need a way to identify the product. So one way we're doing this is using RFID. Again, it's not the only application, but it's the one we work with. And again, we've created a few innovative solutions on that, such as using chipless RFID. A chipless RFID means that it's an RFID tag that doesn't have a chip, which makes it cheaper. So it's a cheaper chip. And interestingly, it actually creates a unique ID for an object. So the moment you place the tag on the object, it actually has a unique ID, and then it goes immediately to the blockchain, so you have a unique identifier. So when the person later on scans the product, they know that's the one they're holding. Every stage within the supply chain is related to the blockchain via smart contracts. So whenever there is any change of ownership or any information about shipping and so on, you actually link it to smart contracts and you can select the rules. For instance, just to give you probably the easiest example on our side is simply temperature storage. So you may have, again, medicine or some kinds of food that require a certain temperature of storage. So you connect it to sensors and you select a smart contract where you basically say, okay, I only accept temperature readings from 2 to 6 degrees Celsius. If I register temperature of 7 degrees Celsius, I want my money back. And here, the moment the data from the sensor reaches the smart contract and it says, okay, that number is out of range, it triggers the execution of a contract, you get your money back. So this is the really interesting application for the future of supply chains, because most of the use cases there are actually, they have a lot of arguments, a lot of fraud, and typically a dispute in a supply chain takes 2-3 months to resolve. And during those 2-3 months, the company in dispute doesn't have access to the money, liquidity problems. And if we're talking about food or medicine that can expire, that's terrible, because you may have, you know, a shipment worth millions of dollars and it's stuck in a port and the authorities are dealing with it, but your product is literally, you know, is going to be worthless maybe in a week. So these are the use cases where automation of processes can be a huge benefit. And some examples, I mean, there's an application that shows you the origin of the product, so you can scan it and you see all the stages through which the product went. And when you go under the hood, so this is the use case we've developed together with, I don't know why the slides here are so low definition. Should be good on my side. Either way, we've developed it jointly with TÜV. It's a German quality assurance company that mainly do industrial quality assurance, but they also deal with food. So here, the company itself acts as a certification body. So they look at the supply chain, in this case of meat, at the different stages of life cycle, and they record different parameters. I mean, they use a lot of human inspectors. So to them, when we came and said, you know, we can replace all people with sensors, they were not happy because I think 95% of their people are actually doing exactly this. But at the same time, what we can do is optimize the processes, because actually their people use sensors anyway. They need to get the data somewhere. And there are also a lot of parameters of quality that cannot be measured by sensors. So at this conference, we're talking about sustainability. How do you measure child labor? Well, you cannot measure it using any sensors, right? You need to send a person, an NGO, who will verify there is no child labor at this factory, at this farm. I guarantee it. And then the only thing you do need to verify that sensors can guarantee is that your product actually comes from that factory. And maybe you also want to verify that the raw materials input in that factory equals to the output. So that if you certify a factory that can produce, I don't know, 500 bottles of organic wine, switching the topic to organic products, you cannot suddenly have 1 million bottles coming from that place, right? So you can just apply stats, couple it with blockchain knowledge, with blockchain-based data, and then you have the information about it. We also had a use case on vanilla. So we actually tracked all vanilla from Madagascar to Europe, so to Switzerland and France. We work with the biggest importers actually in the region of this product, and we have a documentary about this. So for those of you who are interested, you can search on YouTube Ambrosus Vanilla, and there is a mini documentary movie made by a National Geographic team, so it's actually beautiful to watch, where you can see it in practice. So for those of you looking for, you know, how does the blockchain work in practice, and can it work in remote areas? Well, we did it in northeastern Madagascar, one of the least connected areas in the world, and we track the vanilla bundles all the way from there to Europe. And vanilla is one of the most expensive agricultural commodities in the world. It's more expensive than silver, actually. We also had use cases similar on olive oil, which is another problematic area, with a lot of adulteration, a lot of counterfeit activities, and so on. And we've also made use of these smart boxes. Basically, the moment you open the cap of the box simply sends a message: "I've been opened." What this means? You don't trust the contents anymore. So these are some of the examples of the applications of our technology to the supply chains. We're also working on a number of others. So from that perspective, this is kind of just to give you a glimpse. For those of you who are interested to know more, I'll of course be happy to dig deeper into this, because each of these projects can be worth a talk. So I'm giving you a very high-level overview of these. And finally, just a few words on the blockchain. So we've built basically, in terms of blockchain, everybody likes to talk about blockchain. We actually have some of the leading people in the world working in our solutions. So we've made solutions to scalability of blockchain. How do you record a large number of transactions? So we've made it basically with, instead of transactions, we have what are called bundles. And there are 30 of them per block. And there are 10,000 of them, 10,000 transactions per bundle. So we can have about, what's happened here? We can have 300,000 transactions every block, and every block is 5 seconds. So basically it's about 60,000 transactions per second. Huge scalability, and scalability is something you absolutely need if you want to use IoT. You cannot use IoT on Bitcoin or Ethereum, because if you have millions or billions or soon trillions of sensors worldwide, you have no hope they will ever process their transactions on time. So we're also thinking very heavily about large volumes of data stored and scalability. So for those of you who are interested in those technical aspects, I'll also be more than happy to discuss them with you. Thanks a lot for your attention.
Thank you.